Okay, so now we're going to do this last question of the paper. In question 12.1, we are given A and B, which we are told to be independent events. And it is further given that the probability of A and B is equals to 0.3. Probability of only B is equals to 0.2. So 12.1.1 says that are A and B mutually exclusive? So for the fact that we are given the intersection, it definitely tells us that they are not mutually exclusive, right? So P of A and B is not equals to 0. So therefore, not mutually exclusive, right? Because mutually exclusive events have an intersection which is equals to 0. So 12.1.2 says that we must determine the probability of only A, right? So we're going to use the information that we are given here to find the probability of only A. So for us to do that, let's first write the probability of A and B is equals to 0.3. Probability of only B is equals to 0.2. So we want the probability of only A, right? That's what we're looking for. So for us to be able to really get that, we need to draw our Venn diagram, and it's going to look like this, where we have A and B, right? So the intersection is 0.3, probability of A and B. Probability of only B, it's actually equals to 0.2, right? So you're looking for the probability of only A, right? So for us to be able to find that, we need to find the product of A and B, right? Probability of A and B is equals to probability of A times probability of B, right? So we're going to find the probability of A here for us to be able to find the probability of not A, right? So probability of A and B is 0.3, which is equals to probability of A, which is what you're looking for, multiplied by the probability of B, which is going to be the 0.3 plus the 0.2, so 0.3 plus 0.2. So we're going to have 0.3 equals the probability of A multiplied by 0.5, right? 0.3 plus 0.2, 0.5. Divide by 0.5 both sides. Probability of A is equals to, so use your calculator and check. Probability of A is going to be equals to 0.6, right? So the probability of A is 0.6, meaning the entire A is 0.6, right? The entire A is 0.6. But we have an intersection here of 0.3. So for us to find the probability of not, for us to find this probability here of only A, it's going to be the probability of A, right, the entire A, minus the intersection, which is probability of A and B, right? So which is equals to the probability of A, which is what we found to be 0.6, minus 0.3, which would be 0.3. So this is probability of only A. So let's indicate it here, which is actually equals to 0.3. Fine, so we're done with this question here. Okay, so now we want to find the probability of not A or not B, which you can simply find it by saying 1 minus probability of A and B, right? A and B is 0.3, so it's 1 minus 0.3 will give you 0.7. So that is the answer. Okay, now going to do 12.2, right? What we are given here is this. A teacher has 5 different poetry books and 4 different drama books and 3 different novel books. So the total arrangement of these 12 books from left to right. Yes, she arranged them from left to right, as the question, as the statement says here. So now, in 12.2.1, they say write down the probability that a novel will be the first book placed on the shelf. So the probability of the novel is going to be equals to, how many novels do we have? We have 3 novels, right? So it's going to be 3 novels over the total number of books, which is 12. So it's going to be equals to 1/4. So that is your answer. And then going to 12.2.2, calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. So if you have 12 books like this, right, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 8, 9, 10, 11, 12. So if you have 12 books and you don't really care how you place them, you can place them anywhere. Book number 1 can be here, or it can be here. Book number 2 can be here. Any book can be in any position. So which means this just tells us that it's actually 12 factorial, right? So you can find the answer from your calculator. What is 12 factorial? I think you're gonna get something like 479,001,600, right? So that would be the answer. So that is the answer for 12.2.2. And then 12.2.3. Calculate the probability that a poetry book, this is important, a poetry book is placed in the first position. A poetry book, not poetry books, just one poetry book. Excuse me. The 3 novel books are placed next to each other. 3 novel books, not one, just 3. A drama placed in the last position. So this statement is critical here. So we are having a poetry book, and then 3 novel books, and then a drama book. So the first position is a poetry book, just one poetry book. So how many poetry books do we have in total? We have 5 poetry books, right, to choose from. So hence we're just going to write 5 here. 5 poetry books to choose from, and then we have 3 novel books, right? 3 novel books, so you can just write 3 factorial here because they can be placed in different ways in these 3 spaces that they have, right? And then we have a drama book, just one drama book. But how many drama books do we have? We go to the statement. We have 4 drama books, right, to choose from. So you can simply write 4. Let me write 4. So it's gonna be 4 there, right? But remember, we want the probability that the probability of this placement, right? So the probability of the placement is, yes, we are done with this section. We are done with this. We are done with this. But now, what's missing is the order, right? The placement, right? Making sure that each book is placed in its position, right? So what I mean by that is when you take one poetry book here, how many poetry books remain? 4 poetry books remain, right? And then, okay, here all the 3 novels are used. And then when you take one drama book, how many drama books remain? 3 drama books remain, right? So what you're going to do is this. You're going to say, you're having, so these 3 novel books are going to be treated as one book, right? So the probability would be equals to the placement. So it's going to be 5, which is this 5 here, multiplied by the 3 factorial, which is this one here, multiplied by the 4, which is this one here, multiplied by, so as I said, you have 4 poetry books remaining if we use 1 poetry book in this first placement. So you're just going to write 4 poetry books plus you have 1 novel book. So all these 3 novel books are going to be treated as one novel book. So you're just going to write 1 plus you have 3 drama books if you choose to use 1 drama book out of the 4 choices that you have. So you're just going to write 3 and then you say factorial like this, divided by the 12 factorial, which is the number of books, the total number of books, right? So to do this, we will say let me just use another color. So the probability would be equals to 5 times 3 factorial times 4 times, so 4 plus 1 plus 3, it's equals to 8. So it's going to be 8 factorial divided by 12 factorial, right? So you're just going to punch this in your calculator and you need to get 1 over 99. So this is going to be the answer for this problem here. We are done with the November 2021 paper. Thank you very much for watching up until this end. All the best with your exams. Please subscribe if you haven't subscribed, and comment down below if you need any assistance. My love from me to you, Qiniso Dlamini. Thank you so much for tuning into the channel. Peace. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.